In this video, we'll show you how to make an LED surface source property for TracePro. To do this, we'll use the TracePro Surface Source Property Generator utility and an LED datasheet. The first step in the process is to open the Surface Source Property Generator utility from the Utilities menu of TracePro 7.0. The Surface Source Property Generator utility is made up of 4 windows. The Wavelengths Editor window is where we'll enter our spectral information for the LED. The Beam Shape Profile Editor is where we'll enter the angular distribution information for the LED. The Angular Profile Selector allows you to define multiple azimuth angles for non-symmetric LEDs. We'll cover this more in our next video. And the Source Beam Shape 3D preview. This will show us a 3D representation of our beam shape as we're going along. The next thing we'll need to make our LED surface source property is an LED datasheet. In this case, we're going to use the datasheet for a Luxian Rebel LED. From this datasheet, we're going to use the spectral distribution graph and the angular distribution graphs. So here's an example of a spectral distribution graph for neutral white. And here's an example of the angular distribution, either in rectangular format or polar format. And we can use either of these to generate our property in TracePro. Now we're going to define the spectral distribution properties for our LED surface source property. To do this, we're going to use the Wavelengths Editor window in the Surface Source Property Generator utility. If you click on the Helper button in the lower right corner of the Wavelengths Editor, it opens up the Spectrum Input Helper window. This is where we're going to paste the graph from our LED datasheet to use as a basis for defining our spectral distribution. If we go back to our LED datasheet, in this case we're still going to use this neutral white LED spectrum, and we're going to cut and paste that into the utility. So we're going to cut and paste this just using the Windows clipboard. And then in the Spectrum Input Helper window, if you right click and choose Paste, it'll paste in that neutral white spectrum. We can drag this window open a little bit larger so we get a little more detail in our graph. Now if you notice, this graph goes from 400 to 800 nanometers, and although there's no units defined on the left hand side here, we're going to assume it goes from 0 to 1. And the first step in our process here is going to be to define the limits of this graph. So we want to define this lower left hand corner and upper right hand corner. And to do that, we're going to use this Set Reference 1 and Set Reference 2 buttons here in the bottom of the screen. The wavelengths, as we said, are going to go from 400 to 800 nanometers. If you remember in TracePro, wavelengths are in microns, so our lower left corner here is going to be 0.4 microns. Our right hand side of the graph is going to be 0.8 microns, and our intensity is going to go from 0 in the lower left corner to 1 in the upper right hand corner. So first we click Set Reference 1, and we bring our crosshairs over here and we align them with the lower left hand corner of the graph, and then we do a left click of the mouse, and that leaves behind a little marker defining that as a reference point. Then we can do the same thing here. We can click Set Reference 2, and this is going to be 0.8 microns in 1, so this is the upper right hand corner of the graph. We bring our crosshairs over there, we left click, and we leave a marker to set the reference. So we've now set the limits of this graph going from 0.4, 0 to 0.8, 1. Now that we have the limits of our graph defined, we can trace the spectrum of the LED using the graph we imported as a template. To do this, we can just position the crosshairs over the line on the graph and left-click to insert a point. And we can just do this all along this curve. And we start to add in points and fill in the curve. And what we're looking to have is the green line of the curve follow the original curve for the LED spectrum. The more points you add in, the more accurate the curve will be. We can add a few more in here. You can move these points around once you've added them. If you see, as you hover over one of the points, the cursor turns to a finger, and you can left click and drag that point. So if you moved a point on or off the line, you can move it back into the correct position. You can also delete a point by hovering on it, right click, and choose delete. So it allows you to edit your curve even after you've entered in the data points. Once you have enough data points in that you're satisfied with the way the curve looks, we want to define the number of sample points that we're going to use to export this graph. The default setting is 10 here, where it says auto sample. If we clicked the sample button here, we can see over in this window here the 10 points that it would output, and then in the spectrum data window the actual wavelengths and their weightings or values that they're going to export. Now 10 points probably is not enough to accurately sample the source, so we're going to increase this to 50 and click sample, and you can see here now we've filled in more points. We have a better representation of the curve. We have now 50 wavelengths over here in the spectrum, in the spectral table. And this is what we'll use when we actually export this property now to TracePro. It'll export 50 data points for the wavelengths. There's a box here marked units, and the options are radiometric or photometric. And you'd want to choose this to match how your spectral data is defined. More often than not, you're going to find this spectral data is defined in radiometric units, so it's watts per nanometer. Unless you specifically know that your data is in photometric units, so lumens per nanometer, you should leave this setting set to radiometric. You'll see here the program or the utility will give you an estimate of the CCT, the color correlated temperature. In this case it's about 4600 Kelvin, as well as the CRI, or color rendering index, 92.4 in this case. This is all we need to do to define the spectrum for this LED surface source property. The next step in the process will be to define the angular distribution properties for our LED surface source property. And this is going to be done in a manner very similar to what we just did for entering our spectral data. First off, I'm going to close the helper window here, and then move this window out of the way to give us a little more space. Now we're going to be looking at the beam shape profile editor. And we're going to do a very similar process here. We're going to cut and paste the angular distribution graph from the LED datasheet into this window. As I mentioned previously, we can work with either a polar graph or a rectangular graph. And you can switch between the two just by toggling the type here under coordinate system. In this case, we're going to do the polar graph. So if we go back to our datasheet and then scroll down to the angular distribution graph, and here's our polar angular distribution graph. And once again, I'm going to cut and paste this using the Windows clipboard. And then I'm going to do a right click and paste that into our beam shape profile editor. Once we've pasted the angular distribution graph from the LED datasheet into the beam shape profile editor, we'll need to define the limits of the graph. And we're going to do this very similar to what we did when we defined the limits in the spectral distribution previously. Down here you see we have 3 buttons now for defining the graph limits: the origin, reference 1, and reference 2. To set the origin, we're going to click Set Origin, and we're going to bring our crosshairs over to the origin of the graph, the 0, 0 point, so right in the center, and then left click to leave a marker. Reference 1 will be at an angle of 0 degrees and a value of 1. We're going to assume this graph goes from 0 at the center to 1 on the outer edge. So we're going to click Set Ref 1, bring our crosshairs up to 0 degrees and 1, and left click to leave a marker. And we're going to do the same thing for Set Reference 2, only in this case it's going to be somewhere along the 90-degree axis here, and it doesn't need to be in an exact value. So we're going to click Set Ref 2, come over here to the 90-degree axis, and leave a point by left clicking. And you can see it actually fills in a value of about 0.95. So now we've defined the limits of this graph, and we'll be able to start entering our angular distribution data. To define the angular distribution for our LED surface source property, we can simply left click on the curve, just as we did for the spectral distribution, and trace the original graph from the LED datasheet. As with the spectral distribution graph, you can drag points around by hovering on them, left click and drag them, or by hovering, doing a right click and choosing delete. The default setting for the beam shape profile editor is for a symmetric input. This means that as we add a point to the right side of the graph, it's duplicated on the left side of the graph. If you had a property that had a non-symmetric distribution, you could deselect symmetric input, and then you could enter values on both sides of the 0-degree line to define your non-symmetric input. And as we are defining points here, we can look here at the source beam shape 3D preview, and it'll show you a 3D representation of the beam profile you are currently defining. If you're working with an LED that has a non-symmetric output in the azimuth axis, such as an LED with a lens that may have an elliptical output, you can use this angular profile selector to add additional angular distribution profiles. We'll cover this more in our next video. The last step in the process is to export the property to TracePro. You can do this by choosing Export in the top menu and opening up the Export to TracePro dialog box. We can then give this a catalog name, video example. We could also give it a property name, video LED, and we could give it a description if we want. The azimuth angle here is grayed out because we've only defined a single azimuth angle in this property. You do have the option here of defining the number of polar angles you'd like to include. In this case, we're going to leave it at the default setting of 30. You can define the temperature for the property, but we'll stay with the default setting, 300 Kelvin. And the last step is to define the emission, or the output of the LED. In this case, we're going to define it as 1 watt radiometric. Some of the other options you have here are radiometric irradiance with watts per meter squared, photometric illuminance is lux, or photometric flux is lumens. The thing to be careful about here is, as I mentioned when we were defining the spectral properties, is you want these units to match the way your spectrum was defined. So in this case, we're in radiometric units, and we're going to stay with radiometric flux watts. And lastly, we can click Export. If we now go to TracePro, we can see that it has opened up the message macro window. It has a small #T here, which means this property has been successfully exported to TracePro. We could now go here to Define, Edit Property Data, and Surface Source Properties. And this opens up the Surface Source Property Editor. And under Catalog, if we scroll down to Video Example, and then under Name, we go to Video LED. Here's the property we just created and exported to TracePro. We see the wavelengths go from about 0.41 microns up to 0.78 microns. Here we see the polar angles that we defined, our single azimuth angle, and as well as the emissivity value for each wavelength and polar angle. And we can also see here we have our emission is 1 radiometric watt. To wrap up this video, let's review the steps we took to generate this LED surface source property for TracePro. First, we opened the Surface Source Property Generator utility from the Utilities menu of TracePro 7.0. Then, we cut and paste the LED spectral graph from the LED datasheet into the Wavelengths Editor window. Then we defined the upper and lower limits of the graph, and then clicked on the graph with the left click of the mouse to define the curve. And finally, for this window, we defined the number of sampling points we wanted to use in the Auto Sample button. The next step was to cut and paste the angular distribution graph from the LED datasheet into the beam shape profile editor. We then defined the limits of this graph, just as in the spectral graph, and then finally clicked along the curve to generate the curve for the property. And the last step in the process was to export the property to TracePro from the Export menu. We'd like to thank you for attending our presentation. If you have further questions on our capabilities, please email us at sales@lambdares.com or call us at 978-486-0766. And please check out our other videos on our website. Thank you.